Let's start a new approach of this gravitation that is known as gravitational potential. So basically it is necessary that we should understand what is gravitational potential. So this is the subarticle. Gravitational potential. As we have discussed in the previous theory that every object produces a gravitational field due to their mass around it. So, a characteristic of such field is defined by a quantity and this quantity is known as gravitational potential. And the definition or the actual meaning of this particular quantity is given in this way. The negative of the work done, and it is also the mathematical approach. The work done by the gravitational force in a bringing a body of unit mass from the infinite distance to a given point in the gravitational field. Is called gravitational potential. That is denoted by phi at that point. Now again I am telling you that you should not be confused in this phi, that is gravitational potential, and the another phi that is coming in the magnetic flux. So don't be confused in these two quantities. Now it is necessary, as once we have discussed about the gravitational potential, so it is basically the negative of the work done by gravitational force. So what kind of work you have to perform? You have to bring a body from the infinite distance to a given point, and this point is existing in the such kind of work done is called gravitational potential. The unit of gravitational potential is joule upon kilogram. So why it is joule per kilogram? Because joule is for work and kilogram is the mass of the particle. So the work done for this particular body, and the dimensional formula of gravitational potential phi is given by m0 L2 T minus 2. So you can easily check the unit in this way. So once you are confused that here kilogram into inverse is there and here the mass quantity is zero dimensional, so joule is containing the mass quantity with the power 1 and here the power minus 1. So the resultant is 0. And after solving this, you will get this dimensional formula. Now to analyze the work done by the gravitational force, let me give you some arrangement. So here basic arrangement is given, and now our task is to find out the formula for the gravitational potential, and this gravitational potential we will find out first in Earth's gravitational field. Now here we have put the origin of the coordinate system, means O, we have considered as center of the Earth. The mass of the Earth is me, and re is radius of the Earth. Now, these are some defined quantities, but here our task is for this particular particle, and this particle is situated outside the Earth and it is having the position with respect to the reference point, that is our center of the Earth. So OP vector is the position vector for a particle or any body at point P. And it is denoted by small r. Here, if you find out the magnitude of this position vector, then you will get the distance, and this distance means modulus of r, that is equal to small r. It is greater than radius of the Earth, or it might be equal to the radius of the Earth. And so at this point, the Earth's gravitational force of a body, that means F, is given by minus g mass of the Earth into mass of the second body, and here the body is of unit mass, so I am putting 1 over here, divided by r square into the unit vector r cap. And this force is not constant. Why? Because the value of r is changing with time, and so this force is not constant but changes with the value of distance. So I am taking this result as number 1. So it is the value of variable gravitational force. But if we consider during infinitely small displacement, that is dr, the force value or the magnitude of force is remaining constant over this particular small displacement, and hence during such a small displacement the work done by this gravitational force, that is F. So such kind of gravitational force or the work done is given in terms of dW is equal to force into displacement, and here the displacement is dr, that is equal to minus gme over r square into r cap into the displacement vector dr, and I can write down this value of dr as minus gme over r square into r cap is as it is, and magnitude of dr into unit vector. And so my formula for work done over the small displacement in which the gravitational force is constant, that is minus gme over r square into dr, because the value of r cap into r cap is 1. And so this is my second equation, second important result. Now the entire path, if you see, again I am giving you the image. So the entire path from point P to infinite distance can be divided into large number of intervals. So from point P to the infinite distance, we can consider this particular path, means this is the entire path as we have seen in the definition of gravitational potential, that we have to take this object from infinite distance at point P. So what I am doing, I am dividing this infinite path to the large number of intervals, and in order to find out the work done to take the object at infinite distance to point P, I can take the integration of the small intervals. Actually it is a large number, but the intervals will be small. And so my work done for the distance at infinitive is equal to this r, means this distance to infinitive, and the small element of work I am taking over here, and from equation 2 I am substituting the value of dw minus gme over r square into dr, and therefore wr tends to infinitive is equal to minus GME is common, so I am taking it outside of the integration. R to infinitive 1 over R square dr. And so I can easily take the integration of insider term. Is equal to minus GME. So increment in power by 1. So that will be 1 upon R square. So it is R raised to minus 2. So increment means minus 2 plus 1. So it is 1 over R. But the minus sign will come from R to infinitive. That is equal to minus GME into upper limit minus 1 over infinitive plus 1 over R. And we know the value of 1 over infinitive is 0 plus 1 over R. And so our equation for the total work done to bring the object from infinite distance to a given point, that is minus GME divided by R, and that is my result number 3. So the work done by the gravitational force will be the same as the equation number 3, but with the opposite sign. That means if you want to find out W from infinite to R, that is equal to GME over R. This is just opposite, and this negative work is by the definition of gravitational potential phi. So the gravitational potential at point P is given by phi is equal to minus GME over R, because it is the negative work done, and that is equal to W. R tends to infinitive. But this is the actual equation, and it is very helpful to solve some important applications of space physics. From this gravitational potential, if I want to find out at the Earth's surface, means at R is equal to RE, the value of phi at Earth's surface E is given by minus GME over RE. That is equation number 6. And with this, our analysis on the gravitational potential is over. But it is necessary that we should study something more about this gravitational potential. So the first thing which you have observed over here, the gravitational potential at infinite distance from the center of the Earth. See this infinite distance from center of the Earth, that means O, that is 0. Because from that you cannot bring the object, or the force is not sufficient to bring the object from infinite distance. And the second is the gravitational potential at all points inside a uniform spherical shell is the same. So it is not necessary to find out the gravitational potential at all points, but at one point if you have the value of this gravitational potential, then it will be same at all other points. And for proof of this particular statement, the value of phi will equal to minus gm over capital R, where m is mass of the shell and capital R is the radius of the shell. So these two are main important quantity which appear in this equation. The reason for this gravitational potential remains same at all the points is the gravitational force inside the shell at all the points is zero, and hence no work is done. So work is also zero in the motion of the body inside the shell. And now the work during the motion from infinite distance to surface only comes into the calculation, but we will see it later on whenever it is necessary. Now, the variation in the gravitational potential at the distance r, and this distance is from center of the shell. We have seen in the graphical arrangement, sorry, geometrical arrangement from point P, and this particular change we can see from the following graph. So here you can see the graph from the origin. The object is the distance capital R. This means this is the radius, and the gravitational potential is become minus gm over r inside the uniform shell, and you can see at the all points the value of gravitational potential is same. So at r less than r, the value of phi is minus gm over r. But as soon as the value of r is greater than r, then phi is changing according to minus gm over r. So it is basically depend on this distance, but the nature of that particular quantity will be of hyperbola. And one more thing which you have noticed over here, that as r is equal to r, the value of phi is increasing, or we can say at this particular distance the value will also minus gm over capital R. So with this our gravitational potential topic is over, and now we will see what is gravitational potential energy.